let's solve a trigonometric equation using a Pythagorean identity. Well, this sounds like fun. We're going to solve tangent x plus radical 3 equals the secant of x. And we're going to do this over the interval 0 to 2 pi. Okay. Now, when I look at this initially, I'm like, well, crap. Because solving trigonometric equations is a whole lot easier when you're all in the same function. But here we have tangent and we have secant, and those are not the same. However, you look at your list and you're like, what are all of my identities? What are the relationships between things? And you say, hark, I know that the secant squared of x is the same as 1 plus tangent squared of x. I can say, using that by the Pythagorean identity. Okay, well, that's nice. That puts secant and tangent together, but I don't have anything that's squared. But math is amazing, and that means if I square both sides, I can do that, right? The beauty of math is you can do whatever you want as long as you do it to both sides. So on the left, if I expand tangent x plus radical 3, if I square it, I get the tangent squared of x plus 2 radical 3 tangent x plus 3. And that equals my secant squared of x. Okay, so far so good. And I'm looking at this going, well, where does that take me? Well, now I can say, instead of secant squared x, let's substitute in for our Pythagorean identity. So I'm going to have the tangent squared x plus 2 radical 3 tangent x plus 3 equals 1 plus the tangent squared of x. Well, it's time to move this around. Like, let's get this to equal 0 and see what happens. So I'm going to subtract 1 from both sides, and I'm going to subtract the tangent squared of x from both sides. The beauty, tangent squared of x goes away, and I'm left with 2 radical 3 tangent of x plus 2 equals 0. Well, that beautiful piece right there, now I have just the tangent of x. Well, I can solve this. This is beautiful. I'm going to move that 2 back to the other side. So 2 radical 3 tangent x equals negative 2. I'm going to divide both sides by 2 radical 3. And I'm going to get that the tangent of x equals negative 1 over radical 3. You could also look at that as negative radical 3 over 3 if you would like. So our question is, when is the tangent equal to negative radical 3 over 3? Well, where's the tangent negative? And hopefully you say, well, that's Q2 and Q4. So I can say, well, I feel pretty confident that x is going to be 5 pi over 6 and 11 pi over 6. Well, that's great. I love this for us. However, we need to check our work because we squared this at the beginning. Because if you remember from just math in general, when you square a negative, it becomes positive. When you square a positive, it's positive. So because we squared both sides, we kind of took out any chance of a negative because we squared it. So we need to go back and say, do 5 pi over 6 and 11 pi over 6 both work? So we are going to go ahead and check our answer. So we're going to start by checking the x equals 5 pi over 6. So when I look at my initial equation, tangent of x plus radical 3 equals the secant of x. So let's plug in our 5 pi over 6. The tangent of 5 pi over 6 plus radical 3, does that equal the secant at 5 pi over 6? Well, I don't know, but let's play. So the tangent of 5 pi over 6, as we know, is negative radical 3 over 3. And then we're going to add radical 3. Does that equal the secant at 5 pi over 6, which happens to be negative 2 radical 3 over 3? Well, if we simplified this side, in order to make radical 3 over 1 a fraction, we're going to have to multiply the top and the bottom by 3. So this is going to give me negative radical 3 over 3 plus 3 radical 3 over 3. Does that equal negative 2 radical 3 over 3? Well, on the left, negative 1 plus 3 gives me a positive 2 radical 3 over 3. Does that equal negative 2 radical 3 over 3? Friends, at this point, you could say a negative does not equal a positive. The answer is no. So 5 pi over 6 is not a solution to this. It doesn't work. Positive does not equal a negative. So 5 pi over 6 is not a solution. Okay, let's try the other one. Let's try 11 pi over 6. So again, we have tangent x plus radical 3 equals the secant of x. Let's plug in our angle. So does the tangent of 11 pi over 6 plus radical 3 equal the secant of 11 pi over 6? Okay, so once again on the left-hand side, we know that the tangent of 11 pi over 6 is negative radical 3 over 3. We've done that. And then when we add radical 3, we know that this is going to give us a positive 2 radical 3 over 3, because we just did that. Does this equal the secant of 11 pi over 6? Well, at 11 pi over 6, the secant is 2 radical 3 over 3. So does a positive 2 radical 3 over 3 equal a 2 radical 3 over 3? Heck yes, it does. And therefore, 11 pi over 6 is the only solution on the interval 0 to 2 pi for this particular function, equation. Such fun stuff.